This is R.D. Sharma Solution Class 12 Chapter 17. We are taking the increasing and decreasing functions exercise 17.2. Now show that fx equals to x minus sin x is increasing for all x belongs to R. So we have some trigonometry involved in here. So I'll show you two solutions and I'll explain one solution. That is, there will be three solutions in all and the logic will remain the same. What do we have? Fx is equal to x minus sin x we have. The first thing we do is the differentiation. F dash x, 1 minus sin x will be cos x. So 1 minus cos x is the differentiation. Now this 1 minus cos x should be greater than 0. That is, if it is greater than 0, it will always be increasing function. And this x belongs to R we are talking about. So we are talking about the real numbers, all possible numbers, positive, negative, decimal, any number. Now see here, I am writing it like this. See, cos x range and sin x range is between -1 and 1. The domain is anything. You can put any number in the domain. But whenever we put anything in the x, the cos x will only fall between -1 and 1. It will only be between -1 and 1. So -1 to 1. This is the thing. This is the criteria we are going to use. So this is, you know that cos 0 is 1 and cos pi by 2 is 0. If you remember this thing, these questions are easier to solve. So remembering the graph of cos x or the range of cos x or sin x will immensely help in solving the question. So if you think about it more, just show that 1 minus cos x is greater than 0 with these inputs. So cos x is between what? -1 and 1. As I said, it will always be between -1 and 1. Now multiply both sides by -1. When you multiply both sides by -1, what do you get? The angles will change or the inequality will change. So less than will be greater than will be less than. So when you multiply both sides by -1, what will happen? This will be negative will be positive. It will be 1 plus 1. This is going to be negative cos x, but the inequality sign is going to change. This also is going to change. So we have minus cos x. Here 1 minus 1 is minus 1. Now just add a 1 to all of the numbers. Just plus 1. Here also plus 1. Here also plus 1. So what do you get here? This is 2. 1 minus cos x is, and this is going to be 0. So forget about the left part. Just concentrate on the right part, that is 1 minus cos x greater than 0. I told you earlier, if 1 minus cos x or f dash x is greater than 0, that is going to be increasing in all the real numbers. This is the answer. Now let me show you the solution here. So you need to solve it like this, write it like this. So this is the first solution, this is the second solution. So different ways to do the same question, different ways to write it also. Show that this is an increasing function for all x belongs to R. So we have done question like this, but specifically we just have to show that it is increasing function on this real number. So we'll just differentiate this. F dash x is going to be, x cube is going to be 3x square. This 15 into 2 is 30. So you have 30. X 75 will remain like that. And this minus 50 will be in the differentiation, it will be 0. So if you take 3 common, what are you going to get? X square minus 10x plus it's 25. So now you have x square minus 10x plus 25. And by our previous experience, we know that what it is going to be. X minus 5 whole square is going to be what? A square plus b square minus 2ab. And what is this? This is exactly equal to what we got. So just replace it by x minus 5 whole square. Now you tell me, anything you put x here, because it is square, it is always be positive. 3 is always already positive. So it will always be increasing. Now let me show you those who can understand by example. So I'm giving you an example also here. So we have this 3 has no problem. It is a constant. It is positive. So we don't have to worry about 3. How about the x minus 5 whole square? So I'm putting 1 at one time, -1 at one time. I'm just wanted to show you that it's always be positive. So this is 16, this is -6 whole square, it will be 36. So whatever you do, the square will make the negative as positive. So this term 3x minus 5 whole square will always be positive in any case. That is why this is an increasing function for all x which is belonging to R. I hope you got the idea. Negative square will always be positive in any case, whichever way you want. Now let me show you the solution here. This is the reference which you can follow. Just write these and explain what I have explained. Show that fx equals cos square x is a decreasing function on 0 to pi by 2. So let us differentiate it first. F dash x is going to be, cos square x will be 2 cos x. Differentiation of cos x will be minus sin x. So this is going to be minus 2 sin x cos x. So 2 sin x cos x will be sin 2x. So we have minus sin 2x. So we have to show that it is decreasing. So if you are able to show that this in this interval 0 to pi by 2, it is always negative. That is, it is less than 0. So I am showing it less than 0. This angle will be less than 0. So you have to prove that sin 2x is going to be positive because the negative is already there with us. So we just need to show that sin 2x is positive. So we have x between 0 and pi by 2. Just multiply everything by 2. Everywhere by 2. So 2 into 0, 2 into x, 2 into pi by 2, it is 0. This is 2x, this is going to be pi. 2x between 0 and pi. Now come to add sugar to coffee. And when you see this add sugar to coffee, this 2x. Now when you take this sign, see where the problem will arise if I take sign on both the sides. It will be sin 0, this also sin pi, and you know that sin n pi is going to be 0. So the sin 2x will be between 0 and 0. So that will be a problem. So you don't go like this. I'm just cancelling this out. I'm just showing you that if you go ahead with this kind of solution, you will not be you will be going nowhere. So this is the way. See, everywhere in the first quadrant it is positive, everywhere in the second quadrant it is positive. So it is positive between 0 and pi. Sine will be positive between 0 and pi. This is established from trigonometry also. So if I take the sine of any angle between 0 and pi, it's always going to be greater than 0. That's what I told. And that's what you know from previous experiences. Alrighty. Now what do you see here? We have negative sine 2x. So we have a negative here. So the inequality will change. Multiply both sides by negative here. So sine 2x is minus sine 2x will always be less than 0. And minus sine 2x is what? It is fx. It is the function f dash x, sorry. So f dash x will always be less than 0. When you have differential which is less than 0, that means this function is decreasing function in the given domain. Now let us see the reference solution that you have to follow. You have to apply the logic here and just make the diagram also. It puts lot of plus to your solution. Always diagram is very much appreciated by the examiner. Show that fx equals sin x is an increasing function in negative pi by 2 to pi by 2. So fx is equal to sin x. F dash x will be what? Sin x will be cos x. Now in negative pi by 2 and pi by 2, please remember, pi by 2 is 90, negative pi by 2 is also 90, but on the other side. So when we can show f dash x is greater than 0, that is cos x is always greater than 0, it will be increasing function. So negative pi by 2 to pi by 2, you already know it is always increasing, always positive. Now the second explanation which I can give is this is pi by 2, so this is negative pi by 2. Why I am calling it as negative pi by 2? Because cos plus pi by 2 is negative pi cos pi by 2. You already know that. So 3 pi by 2 is nothing but pi plus pi by 2. When you take the cos, it will be minus of cos pi by 2, which is minus of whatever cos pi by 2 comes. So this negative pi by 2 to pi by 2. So we are starting from here and we are reaching till here. This is the whole area we are talking about. So add sugar to coffee. Where do you see the cos is positive? In the first quadrant and in the fourth quadrant. And in the negative pi by 2 and pi by 2 is also talking about the first quadrant and fourth quadrant. That is why this cos is always greater than 0. That is, it is increasing function. Now let me show you the exact thing which you have to write. So this is just 3 lines you have to write, but the explanation I gave is important. Show that fx equals to cos x is a decreasing function on 0 to pi, increasing in negative pi by pi to 0 and neither increasing or decreasing in negative pi to pi. What does that mean? Let us come to the second part actually. Third part actually. So I am not making the number line. I am just trying to show you what they want. They are saying that we have negative pi and pi. There is a 0 in between. They are asking that this function cos x is going to decrease in 0 to pi. It is going to increase in negative pi to 0 and between negative pi to pi. If a function is increasing also and decreasing also in a given range, that means that function is neither increasing nor decreasing. That is, sometimes it is increasing, sometimes it is decreasing, or vice versa. That means if we are able to show decreasing and increasing in the separate interval, then in the combined interval, it is not going to increase or decrease either. So let us start with our basic things. Fx equals to cos x. F dash x is going to be cos x will be minus sin x. This is minus sin x. Now just show that in between 0 and pi and negative pi to 0. So this is add sugar to coffee. We are talking about. So what does negative pi means? That is important. Negative pi means it's if you place say a mirror in between 0, then pi and negative pi are mirror images. So cos x differentiation is negative sin x. Sin x is positive where? Tell me, where is it positive? It is positive in the first quadrant here and the second quadrant here. So 0 to pi it is going to be positive. We already know that by our trigonometry. Add sugar to coffee, add a means all, s means sign. So between 0 and pi it is going to be always increasing. It is always positive. But you have a negative sin x. When you have negative sin x, the things will change. That is, in 0 to pi, sin x was increasing, but negative sin x is going to be decreasing. 0 to pi. So this is decreasing. Minus sin x less than 0 is decreasing in the given 0 to pi interval. How about negative pi to 0? What is negative pi to 0? If you start from this one and come here, see, this is basically when you come again and again, you take a round, it will be pi, 2 pi, 3 pi, 4 pi like this. So sometimes when you take this angle, sometimes it will be positive, sometimes it will be negative, because sine ranges from negative 1 to 1. That is why you have negative pi and pi. So sine x is less than 0, negative pi to 0, as I just told you, and you multiply both sides by negative, it's going to be greater than 0. So f dash x should be greater than 0. So here it is going to be increasing. Minus pi to 0, it is going to decrease. But since it is negative sin x, it's going to be increasing in this negative pi to 0. And what about the third part, which I answered previously? That is, in the negative pi to pi whole interval, sometimes it is increasing, sometimes it is decreasing. And that clearly shows that it is neither increasing nor decreasing. Please remember, in the third and fourth quadrant, sine is always negative. First and second quadrant, sine is always positive. That is why when you put negative in front, it will be inverted. So this increasing and decreasing and increasing has changed because of the minus sin x. F dash x was minus sin. Now this is the explanation which I gave, and I would encourage you to draw the diagram that will make it more fruitful. Show that fx equals to tan x is increasing function on negative pi by 2 to pi by 2. So in order to show increasing, the differentiation should be greater than 0 in this negative pi by 2 to pi by 2. This is the first thing. I am saying that tan x is there. We will just differentiate it. So differentiation of tan x is sec square x. So this sec square x, when you're talking about negative pi by 2 to pi by 2, first you have to see sec x or cos x where it is positive and negative. So add sugar to coffee again. I am talking about sec x. It is almost this sign in sine or in the negative and positive terms. Sec and cos are almost equal. Actually 1 by cos x is sec x, but negative, if it comes, it doesn't have any difference. So cos is positive in the first quadrant and the fourth quadrant. This is first quadrant and fourth quadrant. So this is sec square x. You see sec x should be greater than 0. In which quadrant? Minus pi by 2, pi by 2. I told you this is pi by 2, this is negative pi by 2. So minus pi by 2 to pi by 2 or pi by 2 to minus pi by 2, it is going to be greater than 0. You already know that because I'm talking about cos x, which is actually the inversion of sec x. So minus pi by 2 to pi by 2 is the given interval. In this interval, if we apply the trigonometry, add sugar to coffee scenario, it is going to be positive. If you square both sides, it's going to be sec square x, which is greater than 0. So you have f dash x, sec square x, which is greater than 0. So f dash x is greater than 0. That means this function is increasing on this negative pi by 2 to pi by 2. Now I told you, and this is the result which you have to write and use the diagram also. Now this is show that tan inverse of this sin x plus cos x is a decreasing function on the interval pi by 4 and pi by 2. So let me differentiate it first. F dash x, the whole effort in this question is only differentiation. I'm telling you. Tan inverse x differentiation is 1 by 1 plus x square. Whatever is there in x, it will be 1 by 1 plus x square. So what is x in this question? Is sin x plus cos x. So 1 by 1 plus sin x plus cos x whole square it will be. And then the differentiation of sin x plus cos x, and sin x plus cos x differentiation is what? Cos x, and then cos x will be minus sin x. So cos x minus sin x divided by 1 plus sin x plus cos x whole square. I am taking the denominator now and I am squaring it. Once this is sin square plus cos square plus 2 sin x cos x. Sin square plus cos square is 1. So 1 plus 2 sin x cos x. 2 sin x cos x can be taken as sin 2x. So it will be 1 plus 1, that is 2 plus sin 2x. So for what we got? Cos x minus sin x divided by 2 plus sin 2x. Okay. Now we have to take this numerator and denominator separately because the pi by 4 and pi by 2 is the given interval where things can vary. Combination of sin x and cos x is given. So this pi by 4 and x in between we are talking. So the pi by 4 is nothing but 45 degree, pi by 2 is 90 degree. So multiply both sides by 2, you are going to get pi by 2 is less than 2x less than pi. So 2x is between pi by 2 and pi. And now you see, add sugar to coffee. If I take, this is pi by 2 and pi. Between pi and pi by 2, sign will always be positive. See, I am talking about pi by 2 and pi, that is 90 degree and 180 degree. In between this, by this diagram, you know sin 2x will always be greater than 0. Now add 2 to both the sides. Then also it will be greater than 0. 2 plus sine 2x will be greater than 0. So 2 sine 2x plus 2 will greater than 2. So if it is greater than 2, it is already greater than 0. So 2 plus sine 2x will always be greater than 0. This is the denominator. So we have established one thing. The denominator 2 plus sine 2x will be greater than 0. How about the numerator? Cos x minus sin x we are talking about. Cos x minus sin x. Okay. Now we have to go to the detail of pi by 4 and pi by 2. I am giving you a very naive example. Sin pi by 4 is what? Cos pi by 4 is what? This is sin pi by 4, cos pi by 4, it is 1 by root 2, 1 by root 2. You know that it is the cos 45 degree and sin 45 degree. How about sin pi by 2 and cos pi by 2? Sin pi by 2 is 1 and cos pi by 2 is 0. So just make a line and just understand that where the sign is sin greater than or less than cos in this particular pi by 4 and pi by 2 interval. Now this 1 by root 2 is here, 0 and 1 I have made. Now sin pi by 4 is 1 by root 2 and sin pi by 2 is 1. So this is the area where sin is there. What are the values which can come when you take the cos of pi by 4 and pi by 2? It is between 0 and 1 by root 2. So now you see here sin x is greater than cos x. So you can just write it as cos x is less than sin x or sin x is greater than cos x. These both things you understood. Now take this side. Cos x minus sin x is less than 0. So cos x minus sin x is less than 0. So the numerator is less than 0 and the denominator is greater than 0. That means when you combine numerator and denominator, it will always be negative. I am saying a by b. A is less than 0, b is greater than 0. That means what? It will be less than 0. The whole quotient or p by q form is going to be less than 0. That is why this f dash x is less than 0. So in this particular interval, pi by 4 and pi by 2, f dash x is less than 0. And in between this pi by 4 and pi by 2, when it is less than 0, it is a decreasing function in this interval. So there are two things which you have to tell. You have to do the numerator and denominator separately, keeping in mind this pi by 4 and pi by 2. Now this is how you're going to do it. These are the steps you're going to follow. And first I told you about the differentiation, then sin 2x, 2 plus sin 2x is greater than 0. Then I told you cos x minus sin x, and that is going to be less than 0. That's how the whole comes to be less than 0 in this particular interval pi by 4 and pi by 2. The interval plays a very important role here. Okay, this question we are going to take in the next session. Till then, thank you so much and take care of yourself.